Hi everyone, this video is going to help with proportional relationships and graphs. Um, it's 2-2 in 7th grade math. It might be a different section if it's in 7th grade accelerated. And I can't remember right now. All right, so this proportional relationship kind of relates a little bit to our last chapter of looking at a ratio or a fraction of something and how two things are related. So let's start with the definition, or I guess this is the way they kind of explain the definition here. So a graph can be used to show a proportional relationship between two quantities. So two quantities just means two numbers, right? So we want a proportional relationship. That means the relationship between them stays the same all the way down the graph. In terms of graphing it, that means it forms a line and it has to go through 0, 0, the origin. So the table shows a proportional relationship between time and the number of heartbeats. Each row of the table can be represented as a ratio. That's what they're talking about. So look, if I take 4 and 6, do those have the same relationship as 6/9? Well, think about it. If I wrote them as a fraction, 4 over 6, I'm going to write it on my paper over here. So this is just my first example. If I write 4 over 6, does that equal the 6 over 9? And you could have gone the other way. I did X over Y or time over heartbeats. We can switch it and do heartbeats over time, which is both ways are okay. And it's probably more common to do the opposite way that I just did, but either way will show you the relationship. So 4/6 is going to reduce to, if you divide it by 2 on both, 2/3. 6/9, when I divide both of them by 3, 6 divided by 3 is 2, 9 divided by 3 is 3, and I get 2/3 for both. All right, so I just looked at the first two, and they reduced to 2/3. So 4/6 reduced, 6/9. Now let's look at 10/15. If I divide, and think of it as a fraction, 10 over 15, if I divide them both by 5, I get 2/3. For 12/18, same idea, but if I divide them both by 6, I get, I'm pushing on my button there. If I divide them both by 6, I get 2/3. So that is proportional. So if you're given an X and a Y, X, Y, whatever they represent, you have to check every single X and Y to make sure they're proportional. So they all have to have the same ratio or reduce to the same fraction. So really, we're talking about proportional, but we're really working with fractions again and making sure you understand where they can be used in the real world. Okay, so this one goes on to say each ratio also can be represented as a point on the graph. So let's look at that. And then they say they draw the line through all the points. So we have 0, 0, but we go over to 4, 6, 6, 9, 10, 15, and so forth. And it draws a line and it goes through that origin, okay? And they say each value, each y value is 3 to 2 times the x value. So they looked at y to x, we looked at x to y. Either way, y to x is just where we divide the opposite direction. So 6/4, that would have reduced to 3/2. 9/6, again, 3/2, and so forth. What this means is every time the x value increases by 2, the y value increases by 3. Look, did these go up by 2 each time? Yep. Do these go up by 3 each time? Yep. That's where we get that relationship, 2 to 3, okay, or 3 to 2, either way. Then let's look at my first little problem over here, well, or second problem, I guess. So here are 3 graphs. Which one is proportional relationship between x and y? What were our rules? They had to form a line, and they had to go through the origin, 0, 0. Well, that one's not a line, right? So that C's out. B, does it go through 0, 0? No. A is your answer. Okay. Okay. Now let's look at just a table here. This would just be my second example that I'm writing on paper. What if I have this little XY table and it goes 0, 0, 1, 6, 2, 12, 3, 18, and 4, 24. I'm going to ask you to make a graph and to tell me if this is proportional. Okay, yes, proportional or no, and I want you to make the graph. All right, so let's start with the graph because that'll tell if it's us really if it's proportional. Let's see. I didn't feel like getting out a ruler. Here is our point 0, 0. Okay, so we have that point 0, 0, 1, 6. Let's see. I'm gonna have to count kind of by big here numbers. So maybe I'll go 1, 2, 3, 4, 5, 6. So this would be 6, 1, 6 because it goes all the way up to 24. I don't know if I'll quite have room to graph the whole thing. 2, 12. Well, if this is 6, this would be 9, and that would be 12. So we have 2, 12, and then 3, 18. So 3, 18 would be here. 4, 24. So I did good. I fit them all on. Do those form a line? Well, yeah. And do they go through the origin? Yeah. My graph's not perfect, but close enough. It doesn't quite. Maybe I needed some graph paper. So either way, you can see it there and it graphed, and you can see that it goes to the origin and that it goes in a line. How else can I double check? Do these count by ones each time? Yep. So these are going by ones right here. And what are these going up by each time? Sixes. Sixes, right? So our relationship is 6 to 1 or 1 to 6. Okay, I think we should probably stick with y to x. Y to x. So that's 6 to 1. Every 6 y's, we go up 1x. This one didn't have a relationship, like I didn't label what x and y were to say what they're going up by. Okay, so what if I'm given like a formula like y equals 4x, and they ask, okay, is this proportional? What are some ways I can know? Because that's kind of a hard problem. Like, I don't know. Well, I can put in some numbers and see if they come out proportional, but it's actually easier than that. So think about this. If I put in a 1, I was going to, for x, so let's just look at some values. I'm making up what I'm putting in. So put in 0, 1, 2, 3 or something like that. Let's start with 0. So for x, I'm going to just pick a number. So 0. What is 0 times 4 to find your y value? So 0 times 4 is 0. So y is 0. Hey, we have that point 0, 0, right? Now, that's the first thing you want to check. If I put in 0, do I get out 0? That really is the main thing you need to check, because as long as it's a y and an x, there's no x squared, x to the third, a square root in there, or anything other ugly symbol that we don't really want in there, then it is going to be proportional. But let's try a couple more values. Let's put in a 1. What is 1 times 4? 4. Let's put in a 2. What is 2 times 4? 8. Let's put in a 3. 3 times 4 is 12. Then we could graph those like we did the last one and make sure it goes through 0, 0 and it forms the line. That's another way to do it. You could always graph them. And you could use technology to try graphing it, but I don't really care. I would prefer you do it all by hand in 7th grade until you're a little older, and then graphing calculators are awesome and can help you with that too. So let's look at another equation, because those ones are a little hard. Let's see. So what if we have y equals 3x plus 1? Oops, can't see it. Y equals 3x plus 1. So let's start with our just random values, but we want to probably always go 0, 1, 2, 3. Like that's just, I don't want to put in 55 or something big, and I want to go consistent so I can see the pattern. So I'm going to start with 0. Now this one I'm going to have to write out and show a little bit of works for. So y equals 3 times 0 plus 1. Again, I made up 0 and I put it in for x. And remember, when the x is right next to 3, it means times. So 3 times 0 is 0. 0 plus 1 is 1. So when I put in 0, I got out 1. Is this proportional? I already know the answer. No. I can't have 0, 1. I have to have 0, 0. So no, not proportional. That's why we always want to check our origin first. Okay. Then there was a couple where they used like, I'm going to just show a graph. This one was distance run by a cheetah. So they have time and distance on the graph, right? I just want to point out a couple things. If you're at 0, 0, you have gone 0 time and 0 distance, right? That makes sense. If I haven't gone any distance, well, no time has passed. So that's what that means. What does it mean when I say I'm at 1? I think these are these are 1 second, I guess, seconds. Okay, what does it mean when I'm at 1 second? Where am I for distance? Well, I go up and look. I'm at 90 feet. All right, so you can look at the graph and find missing, and you can see the relationship is 1 to 90 or 90 to 1, because you probably want to take y divided by x, right? So 90 divided by 1 is that relationship, 90 to 1. So that means every 90 feet I have gone 1 second, right? And that kind of follows the pattern of if I've gone 3 seconds, I've gone 270 feet and so forth. So some of them make you read the graph. Y, x, y divided by x is the pattern we probably want to stick with. But again, it doesn't really matter too much. All right, so when you get to those that challenge problem, just remember to think of your cups over, right, is your x, and your calories is your y. Remember to think of the relationship as y divided by x on one of your points that you can see. Okay, so I can see over 2 up 280, right? So that's the point, 280. So if I take 280, my y, and divide it by 2, I get my ratio or my proportional relationship, right? All right. Good luck on your homework.